Module 1, Lesson 17, from rates to ratios. So in yesterday's lesson, we went from ratios to rates, and now we're going to go the other direction. We're going to be exposed to some rates, and we're going to figure out the ratios that go with them. All right, so learning targets, we are definitely working on the second learning target as we work with rates and unit rates. But of course, when we're dealing with rates, we are working with ratios, so we have learning target 1 and 3 also. All right, some I can statements. I can find a ratio that goes with a rate that is given to me. Someone gives me a rate, and I can say, hey, I can figure out the ratio. And there are a couple of special situations that we want to make sure we can take care of. Find the ratio that goes with a rate when the second term in the ratio is 1. So I get a rate, and when I write the ratio, the b value, or the value of b, is going to be 1. Second, find a ratio that goes with a rate that is given to me when both terms in the ratio are whole numbers. So we get a rate, and a and b, when we figure out the ratio, both of these will be whole numbers. No decimals, no fractions. And then I can explain that all ratios associated with a given rate are equivalent because they have the same value. So I can figure out that if I have a rate of $5 per hour, that all of the ratios that go with this rate are equivalent, which should make sense because we've hit really hard that the unit rate is tied and the rate is tied to the ratio value, and ratios are equivalent because they have the same value. All right, so take a look at what we're going to accomplish today. So given a rate, you can calculate the unit rate and associated ratios. So we will get a rate, and we will have to scale it to find the unit rate. Once we have the unit rate, we should be able to find ratios that are equivalent to that. And of course, once we have done that, we're going to recognize that all ratios associated with the given rate are equivalent. All right, so example 1a. So we have a ratio, and we want to write it as a rate. The ratio of miles to the number of hours is 434 to 7. So I have a ratio, 434 to 7. My ratio is miles to hours. And if we want to write that in a rate unit form, I have miles per hours, or miles for hours. Miles per hours is what we were using in the last lesson. So I have a rate of 434 divided by 7 miles per hour. So I'm going to do a little work here with the 434. And I'm going to do a little scaling here. I'm going to scale down and scale down. I'm going to divide by 7. I'm going to divide by 7. I have no idea if 434 is divisible by 7. I'm just going to see what I get. 434 divided by 7. 6 times 7 is 42. Leaves me 14. I lucked out there, so I have 62 to 1. Now right here, my brain should be screaming at me. I have a ratio where the value of b is 1. That could be a connection to our learning targets. And so when I write this, I can write my rate here as 62 miles per, not hours, per hour, because it's 1 hour. So I have taken this ratio, the ratio of miles to the number of hours, 434 to 7, and I have converted it to a rate. I have a unit rate of 62, and I have a rate unit of miles per hour. And that should be very familiar to what we did in the last lesson. All right, so I've got a ratio. I need to write it as a rate. The ratio of the number of laps to the number of minutes is 5 to 4. So I know that I've got a ratio of 5 to 4. I know it will have a ratio value of 5/4. I know that I am working with the number of laps to the number of minutes, so I have laps per minutes. So I have a rate unit, and I've got this 5/4 here that is in some way going to be the unit rate. And of course, if I want to take this and get it to a unit rate, I need to scale it down. I need to get down to 1, so I'll divide by 4. And I need to divide by 4. And 5 divided by 4, 1 times 4 is 4. 1 and 1/4. If I want it as a mixed number. Otherwise, I could just leave it as 5/4. These two things are equivalent to each other. So I could have 1 and 1/4 laps per minute, or I could have 5/4 laps per minute. And both of those are saying the same thing. They both have a unit rate. They both have a rate unit. So I have taken the ratio and I have written it as a rate. All right, so going to visualize a little more carefully what we did in the last example. So we're going to take the ratio and we're going to say that the ratio of the number of laps to minutes is 5 to 4. So I'm going to write the ratio. And we figured out that the unit rate was this fraction 5/4, although I also wrote it as 1 and 1/4. And the rate was then also 5/4 laps per minute. And here in the rate, I now have my unit rate and my rate unit. So just visualizing the process that we went through in the last example. All right, here we go. Example 2b. So we are now going to complete the model, and we're going to use the rate listed below. So they give us a rate of 6 feet per second, and they want us to come up with the unit rate, and from the unit rate, they would like us to come up with the ratio. Well, because this is a rate, I know that my unit rate is right there. So I know that I have a 6, and for the unit rate, it is 6 feet per 1 second. So I'm going to have a 6/1. And you'll remember, here's the learning target again. We're looking for ratios that have a b value of 1. So now I can take my unit rate and I can take and say I've got 6 to 1. So I've now taken a rate, and I like to think of it as unpacking. There's a whole bunch of information packed into this, and I have spread it out and thought about what it means. And now, if I wanted to extend my thinking, I could come up with ratios that are equivalent to 6 to 1. I could scale up and have 12 to 2. I could scale up some more, have 18 to 3. I could scale up some more, have 24 to 4. And all of these are going to be equivalent to this unit rate and are going to be equivalent to this rate, which was another one of the I can statements for today. That we can see that all of these ratios are equivalent to each other because they all have this value of 6 to 1. All right, example 3a. Dave can clean pools at a constant rate of 3/5 pools per hour. And they're asking, what is the ratio of the number of pools to the number of hours? Well, I need to take this apart. I know that I've got 3 pools per 1 hour, which means that I have a unit rate of 3 over 1, which means I have a ratio, 3 over 1, silly me, 3 pools per 5 hours. So what I've done here is I've taken the 3 and put it with the pools. I've taken the 5 and put it with the hours. So I have taken this rate here and I have unpacked it to find the information. So then I have this value, this unit rate of 3/5, and I have a ratio of 3 to 5. What I did up here is kind of important. That I took apart this rate and connected the pieces to each other. Now, using this ratio of 3 to 5 and this rate of 3/5 pools per hours, the question is, how many pools can Dave clean in 10 hours? And here is where our friend, the tape diagram, comes back. Let's think about what this ratio looks like. I've got pools, and I've got hours, and I know the ratio is 3 to 5. And the question is, what if the number of hours is equal to 10? And right now you should have light bulbs exploding in your head saying, hey, wait a minute. This looks just like what we did earlier in lessons. So we have this 10, and we can see that it is divided into 5 pieces. And I find out that each one of them is equal to 2. And so each of these is equal to 2. And I find out that the number of pools that he can clean in 10 hours, Dave can clean 6 pools in 10 hours. And I did this by taking the rate, finding the unit rate, taking the unit rate and turning it into the ratio of 3 to 5, and using the ratio of 3 to 5 to create a tape diagram using the information given in the problem. All right, example 3C. Dave can clean pools at a constant rate of 3/5 pools per hour. By the way, does that mean he's cleaning more than 1 pool an hour or less than 1 pool an hour? Now, hopefully you're recognizing that 3/5 is a fraction, and so in an hour he's cleaning less than 1 pool. So it's going to take more than 1 hour to clean a pool. So a little bit of number sense there. So Dave is cleaning 15 pools. Well, I've got my unit rate of 3/5, and that is going to become a ratio of 3 to 5. And I've got my pools, and I've got my hours, and I've got my ratio of 3 to 5. And it says 15 pools this time. Now, it's important that I read the sentence here and figure out what information is being given to me. I've got 15 pools. And the 15 pools are split into 3 pieces, and 15 divided by 3 is 5. And so if these are 5, all these pieces for the pools, all the pieces for the hours are 5. And I'm going to find out that it is going to take Dave, it will take Dave 25 hours to clean 15 pools. And once again, I found all of that by looking at the rate, connecting the rate to the ratio so I can represent the ratio using our tape diagrams. All right, Emmeline can type at a constant rate of 1/4 pages per minute. What is the ratio of the number of pages to the number of minutes? Well, the unit rate here is 1/4. So my ratio is 1 to 4, and the 1 connects to the pages, and the 4 connects to the minutes. So 1 page in 4 minutes. All right. So Emmeline has to type a 5-page article, but only has 18 minutes until she reaches the deadline. Does Emmeline have enough time to type the article? Why or why not? Okay, so we're going to get a little bit more advanced here, but we're coming right back to let's look at this rate and connect it to a ratio. We have a ratio of 1 to 4. We figured that out on the last problem. So I've got pages and I've got minutes, and the ratio is 1 to 4. And she needs to come up with 5 pages. Okay, so the number of pages needs to be 5, and the 5 is only in 1 unit, so this is a 5, and these would be 5s, and I would find out that Emmeline is going to need 20 minutes to complete this task. So does she have enough time? Emmeline does not have enough time. And I need the why or why not. She needs 20 minutes. To type 5 pages. She just doesn't have enough time. So this next question, she has to type a 7-page article. Well, I've got my pages to my minutes. And I see that she's typing 7 pages this time. And that would take 28 minutes. It will take 28 minutes to type 7 pages. Oh, we already did this one, so I'll skip to the next slide here. All right, Xavier can swim at a constant speed of 5/3 meters per second. So I know that I've got this 5/3 as my unit rate, and I know that that is going to be a ratio of 5 to 3, and it's meters and seconds. So the 5 connects to the meters, the 3 connects to the seconds, and the ratio of the number of meters to the number of seconds is 5 to 3. And we're going to use that to answer a couple of questions. So my ratio was 5 to 3. Xavier is trying to qualify for the national swim meet. To qualify, he must complete a 100-meter race in 55 seconds. Is he going to qualify? Why or why not? All right, well, I know that I've got meters. I know that I've got seconds. I know that I have a 5-to-3 ratio. And I know that the meters are 100. And I want to know how long it's going to take to swim those meters. So he's trying to swim 100 meters. And I see that the 100 meters is divided into 5 parts, 100 divided by 5. So each of these is 20. And because I have a ratio, I know that each of these are 20. And I see that it's going to take Xavier 60 seconds to swim the 100-meter race. Xavier will not qualify. It will take him 60 seconds to swim 100 meters. All right, let's take a look at the next one. So once again, we're working with our ratio of 5-to-3. And that is meters and seconds. Xavier is also attempting to qualify for the same meet in the 200-meter event. To qualify, Xavier would have to complete the race in 130 seconds. Will Xavier be able to qualify in this race? Why or why not? All right, so I know that my meters is 5. And the seconds are 3. And I know that he's trying to go 200 meters now. And I see that that is split into 5 parts. 1, 2, 3, 4, 5. 200 divided by 5 tells me each piece is worth 40. And each of these is worth 40. And I see that it would take 120 seconds for Xavier to swim the 200 meters. So will he be able to qualify? Yes! He will qualify. It will take him 120 seconds to swim 200 meters. All right, let's look at the next one. The corner store sells apples at a rate of 1 $2,500 per apple. And I need the ratio of the amount in dollars to the number of apples. Now on this one, I need to notice that I don't have the fraction going on. The last couple that we looked at, we had the fraction, a ratio of whole number to whole number. And it was really nice to look and just see the fraction and say, oh, here's the 2 parts of my ratio, thinking about our I can statements. But in this one, we've only got one number. All we have is the 1 $2,500. Where's the other part of the ratio? Well, the other part of the ratio is right here. It says per apple, singular. So we're talking about 1 apple here. So our unit rate is actually 1 $2,500 to 1. So thinking about our I can statements here, writing a ratio where B is equal to 1. So the ratio of the amount of dollars to the number of apples is 1 $2,500 to 1. And I'm going to write that up at the top so that I can hang on to it and use it for the next problem. So Akia is only able to spend $10 on apples. How many apples can she buy? Now this one is a little bit tricky to think about with tape diagrams. It's not really going to look very nice. So maybe we need to use a different strategy on this one. Maybe this time I am going to use a table of equivalent ratios. I've got dollars and I've got apples. So what I could do here is put in my dollar amount and my apple amount. I could double and say if I had 2 apples, I would be $2.50. I could double that and have 4 apples and have $5. I could double the 4 and have 8 and get $10. And I could find out that it is going to cost $10 to get 8 apples. She can buy, Akia can buy 8 apples for $10. Now I also could have gone straight to the 8 apples. Because I have this value of 1 for the apples, and I know, oh, let me step back there. Try and say this a different way. I know that the ratio of dollars to apples is $1.25, and I want to find out how far the $10 goes. So I could take the $10 and I could divide it by $1.25 and see how far things go. And this is division we haven't so much practiced this year. But you wind up with 1,000 divided by 125 and you get 8. So I could scale this up by multiplying by 8 to get $10 and multiplying this by 8 to find out that there are 8 apples. But I really like the more simple scaling that I was doing of just moving the apples upward. So saying how much would it cost for 2 apples? And of course, right about here, my brain screams at me that I know that $2.50 multiplied by 4 gets me $10. And so I really, in my brain, I wanted to go right there. All right. So Christian has $6 in his wallet and wants to spend it on apples. How many apples can Christian buy? So he's got $6. I can once again do my chart here. I've got my dollars and I've got my apples, and I know that I've got a ratio of $1.25 to 1. I can double this, and get $2.50. I can double again and get $4 and $5. I could add one more. So now I'm going to use the additive property here. I can take the 4 and the 1, and I can combine them and find that it's $6.25 for 5 of them. He's only got $6. So the most that Christian is going to be able to buy is 5 apples. He's 4 apples, spending $5, because if he tries to buy 5 apples, he doesn't have enough money. Now I want to step back and look at a couple of these problems in a slightly different way. So I'd like to take a look at Emmeline here with her ratio of 1 to 4. And I would like to briefly look at how we could use a double number line on this problem. So I've got pages and I've got minutes. And she's got 0 pages at 0 minutes. And she's got 1 page at 4 minutes. And now I can continue my double number line. 2, 3, 4, 2, 3, 4. Here's 5. She was shooting for 5 pages, and I can continue my double number line, 8, 12, 16, and 20. and I can use a double number line to see that 5 pages will take 20 minutes. And I could extend the double number line, 6 and 7, to 24 and 28 to answer the second part of this question. So even though I used tape diagrams, something that we're very comfortable with, I could use double number lines on each of these problems. Taking another look at Xavier and his ratio of 5 to 3, I could, of course, complete a table of equivalent ratios. I've got his meters, I've got his seconds, I've got 5 to 3. So 10 and 6, I've doubled them both, multiplying by 2. And now I can scale this up to 100 meters. So I can multiply by 10 and multiply by 10 and find out that it would take 60 seconds to go 100 meters, which is not fast enough to qualify. In the next one then, I can extend my table further, doubling again, 200 and 120, and find out that he would qualify in the 200 meter. So with each of these problems, I can use our different representations of ratios. I could use tape diagrams, double number lines, tables of equivalent ratios. We didn't work on it in this lesson, but you can certainly work on finding the equation and using the equation. So all of the things that we have learned about equivalent ratios can be used to answer these rate questions. So, of course, the big goal of the lesson is that we can go from a rate to a ratio. Somebody gives us a rate, we can turn that into a ratio, and we can then use our knowledge of ratios to answer a question. So a rate of 2/3 gallons per minute corresponds to the unit rate of 2/3, which in turn corresponds to the ratio of 2 to 3. So we have a rate, and from that we can find a unit rate, and from the unit rate we can find the ratio. And all the ratios that go with this rate, all the ratios that go with this rate of 2/3, they're equivalent because they have the same value. So hopefully, as we wind down the lesson here, you are feeling confident that you can take a rate that's given to you and find the ratio. And on top of that, you can use the ratio to answer questions. We have looked, as we have gone through these examples, we have looked at rates that have a second term in the ratio as 1. So the $1.25 to 1 apple. We also looked at both terms being whole numbers, and these were rates like 5 meters per 3 seconds. A and B are both whole numbers, a ratio of 5 to 3. And then hopefully you can show, using all of our different equivalent ratio strategies, that all these ratios are equivalent to the rate. All right, so learning targets. We did a lot of writing ratios, making comparisons. Specifically, we looked at the unit rate within a rate, and from that unit rate, we were able to write ratios and we were able to reason about equivalent ratios. So that concludes Module 1, Lesson 17. Kind of a fun lesson, using stuff that we've already worked on. If you have questions, make sure that you talk to your teacher and make sure you complete your problem set.